Ladies and gentlemen, fellow stargazers and curious minds tonight, I invite you to join me on a journey not just through space, but through a hypothetical moment of cosmic cataclysm, a celestial event that would redefine our very understanding of planetary dynamics and the delicate balance that governs our solar system. Forget the calm, majestic image of Saturn, the jewel of our solar system, with its shimmering halo of icy rings. Tonight, we imagine a different reality. A terrifying, beautiful, and utterly profound scenario. The night Saturn lost its rings. For centuries, Saturn's rings have been an emblem of cosmic beauty, a signature against the velvet blackness of space. They are a marvel of gravitational ballet, composed of billions of icy particles ranging from microscopic dust grains to house-sized boulders, all orbiting the gas giant in a breathtaking ethereal dance. But what if that dance abruptly ceased? What if, in a single cataclysmic night, that iconic splendor vanished? To truly grasp the magnitude of such an event, we must first understand the rings themselves. They aren't solid structures, but rather an intricate, dynamic system. The prevailing theory for their origin suggests they are the remnants of a shattered moon, perhaps a mid-sized icy body that strayed too close to Saturn's Roche limit, the point at which a celestial body, held together only by its own gravity, will disintegrate due to the immense tidal forces of a larger, more massive object. This moon, torn asunder by Saturn's colossal gravitational pull, scattered its icy fragments into an orbiting disk, a process that might have occurred relatively recently, perhaps only tens of millions of years ago. A blink of an eye in cosmic timescales. Alternatively, they could be primordial material that never coalesced into a moon, or perhaps the debris from a spectacular cometary capture and breakup. Regardless of their exact genesis, their existence is a testament to the brutal, yet often beautiful, gravitational mechanics at play in our solar system. They are held in their precise, thin planes by the intricate gravitational influence of Saturn's numerous moons, particularly the shepherd moons, like Pandora and Prometheus, which act like cosmic sheepdogs, herding the ring particles and maintaining their distinct edges. Now, imagine the fateful night. It begins subtly. Perhaps a distant rogue object, a dark nomad from the Oort cloud, that vast icy reservoir of comets far beyond Pluto, is perturbed by a passing star, nudged into an improbable trajectory. This isn't just any comet. It's a colossal body, perhaps a supercomet or a dwarf planet on a highly elliptical orbit, far larger than any typical icy visitor to the inner solar system. Its mass, while minuscule compared to Saturn, is significant enough to exert a measurable gravitational influence. As it plunges inwards, drawn by the sun's immense pull, its path intersects with the outer reaches of the Saturnian system. The first sign of trouble wouldn't be visible to the naked eye. It would be picked up by our most sensitive orbital observatories. Subtle gravitational perturbations registered in the precise orbits of Saturn's outer moons. A slight, almost imperceptible wobble in Iapetus's orbit. A tiny deviation in Phoebe's trajectory. Astronomers, initially perplexed, would begin to run simulations, tracing the source of these anomalies. And then the chilling truth would emerge. A massive dark object, traveling at unfathomable speeds, on a collision course not with Saturn itself, but with its delicate ring system. The initial impact wouldn't be a grand explosion, but a series of terrifying, cascading events. As the rogue object, let's call it Apollyon, plunges through the faint outermost A-ring, its immense kinetic energy would vaporize billions of icy particles instantly, creating a temporary, superheated plasma streak. But this is merely the precursor. Apollyon's true destructive power lies in its gravitational shear. As it tears through the rings, its mass would exert a localized, violent tidal force, disrupting the carefully balanced orbits of the ring particles. Instead of being smoothly distributed, sections of the rings would begin to clump, like a perfectly dispersed flock of birds, suddenly panicking and colliding. The shepherd moons, those silent guardians of the rings, would be the next victims. Imagine a colossal bowling ball rolling through a delicate array of pins. Their finely tuned gravitational influences, which normally maintain the ring structure, would be overwhelmed. Instead of guiding particles, they would begin to scatter them, their own orbits thrown into chaos by Apollyon's passage. Some might be flung out of the Saturnian system entirely, becoming new rogue moons, forever lost to the interstellar void. Others might be propelled into unstable orbits, destined to eventually collide with Saturn or one of its remaining larger moons, leaving fresh impact scars on their ancient surfaces. As Apollyon continues its destructive sweep, piercing through the Cassini division, that iconic gap between the A and B rings, the true devastation unfolds. The tightly packed particles of the main rings, once a harmonious ensemble, would be subjected to unprecedented gravitational stresses. The delicate balance between Saturn's gravity, the particles' orbital velocities, and the subtle forces of light pressure would be irrevocably shattered. Tidal forces would begin to pull particles out of their precise orbital planes, creating a three-dimensional halo of chaotic debris. Rather than the thin, flat disk we know, the rings would literally begin to swell, diffuse, and then, inexorably, dissipate. But this isn't just about scattering. A significant portion of the ring material, having lost its orbital stability, would succumb to Saturn's relentless gravity. Imagine billions of icy fragments, large and small, raining down into Saturn's atmosphere. This wouldn't be a gentle snow. It would be a prolonged, violent bombardment. The upper layers of Saturn's atmosphere, normally a serene expanse of hydrogen and helium, would be lit up by countless re-entry flares, like an apocalyptic meteor shower spanning months, perhaps even years. Each incoming particle would create a flash of superheated gas, a momentary streak of brilliance against the swirling clouds of the gas giant. This influx of water ice and other volatile compounds, alien to Saturn's pristine hydrogen-helium atmosphere, would create new atmospheric phenomena, perhaps even temporary, localized weather patterns unlike anything observed before. The very composition of Saturn's upper atmosphere would be subtly, yet permanently, altered, leaving a faint chemical ghost of its lost adornments. From Earth, the visual spectacle would be devastatingly beautiful. The once distinct, sharp edges of the rings would blur. The gaps would fill with chaotic debris. Over hours, then days, the shimmering brilliance would dim, diffuse, and then, slowly, heartbreakingly, fade into nothingness. Telescopes across the globe, and in orbit, would capture this unprecedented cosmic tragedy in exquisite detail. Each image a painful chronicle of disintegration. The iconic shadow of the rings on Saturn's cloud tops would shrink, distort, and eventually vanish, a haunting reminder of what once was. The loss of Saturn's rings would have profound scientific implications. It would force a radical re-evaluation of ring formation and longevity theories. If the rings are indeed young, as some evidence suggests, then their sudden disappearance might merely be an accelerated version of their eventual fate, as they are slowly, inexorably, drawn into the planet by micrometeoroid bombardment and radiation pressure. But an external, catastrophic event like Apollyon's passage would demonstrate the fragility of such magnificent structures, highlighting the stochastic, unpredictable nature of cosmic evolution. It would underline that even seemingly stable celestial features are subject to the whims of the universe's chaotic dance. Moreover, the event would provide an unprecedented, real-time laboratory for studying planetary accretion, atmospheric chemistry under extreme conditions, and the long-term effects of massive orbital perturbations. Scientists would scramble to analyze the new atmospheric signatures, track the remnants of the ring particles, and model the new, altered gravitational landscape around Saturn. The tragedy, from a scientific perspective, would be a goldmine of data, offering insights into processes that normally unfold over millions of years. And what of Saturn itself? Without its rings, the gas giant would appear starkly different. Stripped of its defining feature, it would still be a majestic world, but its ethereal beauty would be diminished, replaced by a raw, unadorned grandeur. It would be a stark reminder that even the most enduring symbols of our cosmic landscape are ephemeral, subject to the relentless forces of gravity and chance. The jewel of the solar system would become the bereaved giant, a silent monument to a bygone era. The night Saturn lost its rings would be etched into the collective consciousness of humanity. It would be a stark, undeniable demonstration of the universe's immense power and indifference. A powerful lesson in cosmic humility. It would remind us that our beautiful, seemingly stable solar system is a dynamic, ever-changing environment, subject to forces far beyond our control or comprehension. It would be a shared moment of awe, sorrow, and profound scientific revelation, forcing us to look at the night sky with new eyes, understanding that even the most enduring celestial icons are subject to the relentless march of cosmic time and the unpredictable dance of celestial mechanics. It would be the night we understood truly the ephemeral nature of beauty on a cosmic scale. If the idea of such cosmic dramas leaves you captivated and yearning to explore more of the universe, its profound mysteries and potential cataclysms, then you've found your cosmic home. Join our community of explorers and thinkers. Subscribe to our channel to delve deeper into the cutting edge of astronomy, uncover hidden wonders, and ponder the grandest questions the cosmos has to offer. Hit that subscribe button and embark on your next journey through the universe with us.